All right, guys, we are moving on to Target 4 for Unit 8. And Target 4 is kind of like a lot of the targets that we do after we learn some new methods. Target 4 is all about applications of these systems of equations. Now, a lot of times when I teach these, I actually like to teach the applications kind of embedded into the method. Like if we were in school right now, normally I would do it that way. But since we're doing it a little bit different, we're kind of saving it till after we learn all the methods. But really these applications, I know they don't necessarily always seem super real life. Right now we're kind of sticking to some Algebra 1 kind of simpler systems. A lot of more real life systems are much more complicated than this. But at least it gives us an idea of how we might be able to use this. And some of these actually are a little bit more realistic. Like if we look at number 1 here, we've got Mary. She is making earrings to earn money. Her advertising costs are $6, and each pair of earrings costs $2 to produce. If she sells them for $5 per pair, what is her break-even point? Now, we have done some break-even point things before. And really break even is when your revenue that you earn, that's all the money that you earn, equals all of your costs. So again, when you're starting up a company, you need to spend some money to earn money. And revenue is the money that you take in. After this break even point, that's when you start earning a profit. That's when we start making money on that. So the way that we're going to start pretty much all of these systems, you'll notice part A for about all of them here is defining two variables and writing a system. This part's really important, and I am going to be picky on this part, that you are nice and detailed with your naming of your variables. Now, that doesn't mean you have to write a long sentence or anything, but we want to be specific about what we are finding. So realistically, we can use any variables we want to. However, in this scenario, I'm going to think, because I'm asking you on this particular one, this is the only one I'm actually asking you to solve by graphing. Because of that, I'm going to use my X and Y variable. Otherwise, you'll see that I start picking some different letters for the variables. But since we're graphing, I'm going to do X and Y for this. Now, we got to think what depends on what. Now, the money that you're either earning or spending depends on the number of earrings that she sells. So I'm going to say X is the number of pairs, I'll say of pairs of earrings. And then Y is basically your total money. So that could either be your costs or your revenue. Now, that's kind of really what we're thinking about. With a system, you're going to write two equations. Now, this particular one, again, for break-even point, we want to think about her costs, and we want to think about the revenue that she earns. Okay, so we need to write an equation for both. Both have to do with money. So both are Y equals, and again, it depends on the money. So her costs, what does it take her on this to spend? So her advertising costs are $6, and each pair of earrings costs $2 to produce. Now, you got to think about what depends on what. Each pair of earrings costs $2 to produce. So that's going to be 2 times the number of earrings. But those advertising costs, does that depend on how many earrings she makes? No. So maybe she's printing flyers, or maybe she's big time and making some kind of commercial. I don't know what commercial would be $6. But again, these are her advertising costs. That doesn't depend on how many earrings she produces. So that's just going to be a plus 6. So that's how much money she has to spend. Those are her costs. And then we've got another equation for her revenue. How much money does she earn? So she sells them for $5 a pair. So she earns $5 times the number of earrings. So the reason I had this one that we're going to solve it by graphing is because quite clearly these are both in slope-intercept form. So we can graph them pretty easily. So our x-axis is the number of pairs of earrings. And our y-axis then is the total money that we're either earning or spending. Now, again, because of this, little bits bigger numbers here, what I'm going to think about is the number of earrings. Are they ever going to be negative? No. Hopefully her costs on this one, or her money and her revenue and all of that we're going to think about positive. Her costs are going to continue to go up as she's making more earrings, and her revenue is going to keep going up as she's selling more earrings here. So that means I'm going to make this on the bottom 0, 0. So we're going to graph it. Let's start with the 2x plus 6. So we start up 1, 2, 3, 4, 5, 6 up here, and it has a slope of 2. So this line, again, is her costs. That is how much money she has to spend. And again, her costs are going to keep increasing because, again, as she makes more earrings, she's going to have to buy more materials. Now, her revenue starts off at 0 here. Again, this is how much money she's taking in, not her profit. Some of you might be asking, well, wouldn't she be earning negative right now because she hasn't sold any yet or she had to pay costs? Yes, but again, this is her revenue. Revenue means how much money you're actually taking in, not how much money, like new profit that you're earning. So we're starting at 0, 0, and we go up 5 and over 1. And this is her revenue equation. So this is a system of equations. We want to find out where do the two intersect each other. So they intersect right here at the point 2, 10. Now, in a real life situation, you're not going to say, oh, 2, 10, that's an ordered pair. You want to interpret it. Now, I didn't leave a whole lot of room, so I'm going to write kind of small. But I'm going to say when she sells 2 pairs of earrings. Oh, sorry, it's kind of slappy on here. She will break even. Break even. And start earning money after that. So she spends, I'll say she spends and earns $10 out of that. So that's when her costs start meeting her revenue. And after that, she starts earning money. She starts earning a profit. So that's one way. Again, this is simple numbers, small numbers, just so we can graph it easily. But you can maybe see how a business might use obviously a much more complex system, but start thinking about where do the costs, like what are the costs after a certain amount, what is the revenue, and where will they start making money on that one. So kind of a simplified version of a somewhat realistic situation here. All right, let's look at another one here. So Adam and Connor, they're selling boxes of candy. Adam sells 4 boxes of M&Ms and 2 boxes of Skittles, earns $32. Connor sells 7 boxes of M&Ms and 5 boxes of Skittles and earns $65. How much does each type of candy cost? So we are defining 2 variables. Again, this part's important. Now, what I tend to see a lot of people doing is saying, all right, my variables are M&Ms and Skittles. Objects like that can't be an actual variable. You can't say M equals M&M. That doesn't make sense because we have to be talking about a numerical value for that. So we have to decide there are a couple things that M&Ms we could define a numerical value for. It could be how many boxes, could be how many M&Ms are in a box, could be how much they cost. So you really have to read what we're trying to find, and we want to be specific. So how much does each type of candy cost? So we're defining the cost. So I am going to use M, but I'm going to say M is the cost of a box of M&Ms. M&Ms. And then we're going to say I'll use S for Skittles. S is then the cost of a box of Skittles. Okay, sorry, it's a little slappy today. All right, so now we need to write an equation, really 2 equations for this. So we are doing, what I always suggest on this is to look for the total here. Okay, look for totals. Really look for 2 totals. So Adam has a total. Adam earned $32. Connor, he has a total. He earned $65. So when I write my 2 equations, we're going to write one equation for Adam and his $32, one equation for Connor and his $65. Again, those are like your total money here, right? So if we look about Adam here, Adam sells 4 boxes of M&Ms. So if we take 4 and we multiply that by the the cost of the box of an M&Ms, that would be his total, basically like earnings off of M&Ms. And he sold 2 boxes of Skittles, so 2 times the cost of the boxes of Skittles, and that would earn the total money of $32. So it's similar for Connor. Connor is 7 boxes of M&Ms and 5 boxes of Skittles would earn him $65. So now we're at the point where we want to solve this. Now it says solve using the method of your choice. So, all right, I'm going to rewrite them right here. So 4m plus 2s is 32. 7m plus 5s is 65. Might be a good idea. Maybe pause the video, try it on your own, see if you can solve it. Think about which method might be the easiest. When I look at this, they're both in standard form. There's not really an easy variable to get by itself. So I would probably use elimination for this one. Now, again, you can choose to eliminate either the m's or the s's first. I'm going to choose to eliminate the s's, mainly because the numbers are a little bit smaller, the 2 and the 5, compared with the 4 and the 7. I just think they're a little bit smaller. Maybe I'll use the smaller numbers here. So that means I'm going to multiply the top equation by 5. If I do the top one by a positive 5, I have to do the bottom equation by a negative 2 because they have to be same but opposite. So that gives us 20m plus 10s is equal to 160. Don't forget to multiply that constant number at the end. And we get negative 14m minus 10s is equal to negative 130. So this is a nice review of our solving using elimination. So now the s's eliminate. We get 6m is equal to 30, which means m is 5. So now that we have that one answer, now I have to substitute that back in to find my other answer. And now again, you can choose either of those equations, whichever one you want to choose. I picked the first one just because the numbers are a little smaller. So 4 times the number for m plus 2s is 32. So we solve it like a regular 32, sorry. Subtract the 20, and we get s is equal to 6. Sorry, my cursor kind of keeps blending in together here. I think I'm writing too fast. So we get s is 6, and now, again, we have an answer of 5 and 6. Now, normally we wrote our answers as ordered pairs. This one, S comes first, M comes first. Usually we'd go alphabetically, but an ordered pair doesn't make sense. We want to interpret our solution. So we have to say something about M&Ms and something about our Skittles. Now you have to be careful. I tend to see a lot of people say, all right, we sold 5 boxes of M&Ms, but that's not what we defined our variables as. That's why we have to be very particular with that. M is the cost of a box of M&Ms here. So I'm going to say M&Ms cost $5 each. And Skittles, whoa, that looks really messy. Sorry, cost $6 each. It's very delayed today. And we get our solution there. That's what I mean by interpreting. All right. Let's try another one here. Now, number 3 will actually look kind of familiar because we've actually done one just like number 3, and we've actually done it without a system. So there are ways to do this without a system, but really when we solved it before without a system, we were actually solving it basically using substitution without even really knowing it. So we want 2 things. We want the length. So I'm going to say L is our length. And we want our width. W is our width. Those are the 2 things that we want to find. Before, when we did this, we actually solved it just using one variable. But here we're going to write 2 equations. So the length of a rectangle is, when I see is, I think equals. So the length is 4 inches more than twice the width. So we've got twice the width, and 4 inches more than that would be plus 4. Perimeter of the rectangle is 112 inches. So again, is 10 inches there. And so perimeter, we know, is twice the length and twice the width. This is the actual system. Now, some of you may be thinking, well, I could have done that without a system. Like I said, you really could have. We have done this using substitution before. We've actually already kind of put that L in already and thought, okay, well, if I do twice that length, that 2W plus 4 plus the other 2W, we get, 110 on that. Not just 100. Whoa, this erased too. All right, so then we go through and solve it. Again, if you want to pause it, I'm going to pause mine and I'm going to fill in the answers just so you can maybe follow along afterwards. All right, so I unpaused my video. Now you can see I finished my whole substitution method here. Solved it. We get W is 17. Substitute that back in. I put it back into our first equation up here, the L equals 2W plus 4, and get L is 38. So when we interpret this, we would just need to say, all right, that means that our length is 38. And we want to label this. If we go back up and look, it's talking about inches. So inches. And then the width is 17 inches on there. And that's all we need to do to interpret that. All right, number 4 looks a little bit different here. Here it says 2 different lines here. Create a system and solve using, okay, this one I told you to use substitution. Really, we could have used either method. I just said substitution here. So line 1. So really, these are going to be our 2 different equations. It has a slope of 5 and contains the point 2, 3. All right, this goes back to some review from first semester. If we have a point and a slope, which form should we use? Oh, point slope form, right? So y minus the y coordinate, so minus negative 3 is plus 3, is equal to the slope times x minus the x coordinate. And just like that, we have the equation for line 1. Awesome. Line 2, line 2 here. So it has a slope and a y-intercept of 3, slope of 2. So slope and y-intercept. Which form has us as a slope and y-intercept? Oh yeah, slope-intercept form, right? So y equals 2x plus 3. Notice I didn't have you define any variables on this one. We're talking about a line, so an x is our x coordinate, y is our y coordinate. We don't have to define them there. But I said solve using substitution. So we're going to do substitution. One thing that might be easiest is line 1 looks a little bit messy. Maybe I'll make that look a little bit neater. So y plus 3, and you technically don't have to do this. I just think it makes the problem a little bit easier. So I'm distributing up here, and maybe it'll be a little bit easier. Instead of even doing standard form, I can put this one into slope-intercept form as well. Now, it looks almost kind of weird to use substitution here, but we can. If I know that this is equal to y, we can put that into the y for the other equation. Really, a way to think about it is if they both equal y, they both have to equal each other. Okay, so they both equal each other. I'm going to work this one out with you because we are going to get some fun with fraction answers here. I'm going to add the 5x over, and then I'm going to subtract the 3. Sorry, this is really annoying today. 4 equals 7x. And so, yay, we get 4/7 is x. So we get our x coordinate there. Substitute it back in to find the y coordinate. Now, does it matter which one I plug it into? No, I might choose the 2x plus 3 just because the numbers are a little smaller. But again, it really doesn't matter. So 2 times 4/7, again, you can use your calculator for this. We get 8/7 plus 3 right away. I don't know why I put a parentheses here. Right away, I'm going to change common denominators. So 3 is 21/7. 21 divided by 3. So we get y is equal to 29/7. Now this one, since we are actually talking about ordered pairs and everything, I am going to write as an ordered pair. 4/7 is my x. 29/7 is the y coordinate. All right, for the ones on the back, I'm going to start to go a little bit quicker maybe. I'm going to definitely not go as quick through the setup, but I might go a little bit quicker through the solving part of it here. So let's look at number 5. Highest possible score on a history test is 150 points. There are 18 questions in all. Multiple choice questions are worth 5 points each. Essay questions are 15 points each. How many questions of each type are on the test? So again, that question at the end is one of the most important things. Now, is it always going to be a question at the end that you're going to look at? Might not be at the end. It might be somewhere else. You might have to interpret it. But this one is a good one to think, okay, how many questions of each type? So we've got 2 different types. So I'm going to say M is the number of, I'm going to abbreviate here, multiple choice questions. That's supposed to be a question mark. All right, shortcutting it is taking longer. Sorry, questions. And I'm going to say E is the number of essay questions. Okay, so now we need to think about this. Now, again, I really like to think about totals. So the highest possible score is 150 points. That's a total number of points. 150. Again, that's our point values there. That's supposed to say points. Points. Right? And then there are 18 questions in all. In all, we also know that's going to be a total. So 18, that's the number of questions. All right, so let's see things that have to do with points. So I've got points. Multiple choice questions are 5 points. Essay questions are 15 points. So all the points are going to go into one equation. So 5 times the number of multiple choice and 15 times the number of essay. Again, all of the points go into one equation. Now, once you use those numbers once, you are not going to use those numbers again. So when I see 18 questions in all, there's no other numbers to use. But think about what you defined your variables as. M is the number of multiple choice. E is the number of essay questions. So 18 is the number of total questions. That means that the number of multiple choice plus the number of essay is equal to 18. So now we can think about how do we want to solve this system. I'm just going to rewrite it here. So when you're looking at it, I would say there are 2 easy methods. I probably would not choose graphing here, but I would maybe use substitution or elimination. It would actually be your choice. I will probably show my work using elimination. Again, I'm going to pause it and do my work so we can come back. You can try it on your own as well. All right, so I did my work by elimination. I multiplied the bottom equation by -5. You also could have multiplied by -15. I chose the smaller number. I left the interpretation, though, up to the end. Again, it's the number of questions. So that means there are 12 multiple choice questions. And then there are 6 essay questions on this particular test. Okay. All right, let's try another one here. There are 2 boat rental shops at a lake. Best Boats charges $25 per hour plus a deposit of $50. Hal's Boat Rental charges $30 per hour plus a deposit of $15. After how many hours would the 2 rental places be the same? Okay, so this one is one that you kind of got to think about independent versus dependent. What depends on what? So because I see it charges per hour on something, that means one of my variables is going to be not per hour, but the number of hours. And really, when you're going to rent a boat, you want to know the total cost. So you can use whatever letter you want to. I'm going to use C for the total cost. All right, so we've got 2 boat companies. Best Boats charges $25 per hour. So 25 times the number of hours plus a deposit of $50. The Hal's Boats costs $30 per hour plus a deposit of $15. Now, one of the questions I'm going to ask on this is, all right, which boat company would you choose? Now, it could depend on a few things. Keep that in the back of your mind there. Now, realistically, this would be a great one to solve by graphing because they're both in slope-intercept form. However, do we have graph paper that goes up to 50 for that y-intercept or 15? No. Could you adjust your axes? Yes, but let's not mess with graph paper. Let's use one of our other methods. So when I look at this, I see both equations are solved for C. So if both of these things equal the cost, really substitution is going to be an easy method. If the cost for one boat place is 25H plus 50, and the cost of the other boat place is 30H plus 15, those 2 costs have to equal each other. And then we can go through and solve it. This is actually your substitution method. Again, I'm going to pause it. You can pause it too and do the solving on your own here real quick. All right, so I solved it with substitution. I got 7 equals H and 225 equals C. I interpreted this already. After 7 hours, both boat companies, not just Hal's or not just Best Boats, both boat companies charge $225. That's what we're trying to decide. So my question, back to that beginning kind of question, which boat company would you choose? Well, it would depend on how many hours you're going to go out on this boat. If you are going out less than 7 hours, think about which company you'd want to choose, which would charge the least amount. I mean, I think you would want to have the least amount that you would pay for it. So if it were less than 7 hours, you would want to go with Best Boats. Again, it charges a smaller amount per hour, a bigger initial deposit, but a smaller amount per hour there. And then if you were going for more than 7 hours on there, again, you would want to think about, all right, which one would be which on here. So if I were to do more than that, I'm sorry, I just paused it because I realized I was talking about the wrong boat company on which one. So Best Boats charges a smaller amount per hour. So you would want to do 20 if you were going more than 7 hours. Sorry, I was misspeaking and I realized that as soon as I was talking there. So if you're going out more than 7 hours, you would want to go with the one that has the bigger deposit but the smaller charge per hour. So less than 7 hours, I'm sorry, you want to go with Hal's because, yeah, he charges more per hour, but that initial deposit is smaller. But if you were going to go out about 7 hours, does it really matter? No, you would choose either of those, whichever one maybe, you liked it better or something. All right, let's look at these last two. Again, I'm going to especially talk about the setup, and I'll go a little bit quicker through the solving here. So Ellie has $1.30 in dimes and nickels. If 19 coins in all, how many of each coin does Ellie have? So we want to know how many of each coin. So dimes and nickels. Let's do D is the number of dimes, and N is the number of nickels. All right, so there are 19 in all, and she has a total of $1.30. So again, I look for my totals. $1.30 is one total, and 19 coins in all. Now, I don't give any other numbers here, but there's some things that I expect us to know about dimes and nickels. We should know that a dime is 10 cents, so 10 cents times the number of dimes. We should know that a nickel is 5 cents. Now, be careful when you're doing 5 cents. That's 0.05 times the number of nickels. Notice I put that in the equation with the money. All the money matches together in one equation. Now, 19 is the number of coins. So the number of dimes plus the number of nickels is 19. Now, again, it would be your choice which one you would want to use on this. Now, one suggestion for you. Do you have to do this? No. I don't always like dealing with the decimals. If you remember way back in the very beginning of the year, we talked about a way we could get rid of decimals. Since all of them have, well, at least one of them goes out to the second decimal place here, I'm going to multiply everything by 100. So 10D plus 5N, that looks really sloppy, sorry. 10D plus 5N could equal 130. And then I'm going to keep the other one the same. D plus N is equal to 19. Now, again, it'd be your choice. Do you want to solve it by substitution or elimination? Pick one and go. I'm going to pause it and come back. All right, I solved by elimination here. I multiplied through by -5. I just chose -5 because I thought it was a smaller number. Some people might choose to do -10 because multiplying by 10 is really easy. Again, you could have kept the decimals and multiplied, with the -0.05. That would have been fine. I chose to do it without the decimals. We end up getting D is 7 and N is 12. Now, one thing I didn't mention on this. If you get a decimal answer, now, can you get decimal answers in some certain types of problems? Absolutely. But here we're talking about the number of dimes and the number of nickels. Would it make sense to have like 7.3 dimes? No, it wouldn't make sense, right? Now, if we were talking about money, could you have a 7.3 as an answer? Sure, maybe it would be $7.30. So keep that in mind when you're getting your answers. Does it make sense here? So we end up with 7 dimes and 12 nickels. All right, last one. Again, you'll see they all end up being kind of similar here. We've got Derek. He's going to a museum with his family and friends. They pay a total of $215 for 12 people to go. Child tickets cost $15 and adult tickets cost $20. How many children and adults went? So again, how many of each? So I'm going to say how many, or I'll shorten it to the number of children. And we'll say A is the number of adults. Again, I want to specify that it's how many. Sometimes I may be asking what is the cost, but in this particular scenario, we know the cost. So again, I look for my totals. Total of $215 and a total of 12 people. So we've got a money equation. This one's our money equation. Let's look for all the money. Children's tickets are 15, adult tickets are 20. So 15 times the number of children plus 20 times the number of adults is going to be 215. Again, I used those numbers. Once you use them once, cross them off, and a total of 12 people. So that means the number of children plus the number of adults is 12. Now, again, this is another one that it would be pretty easy to solve with substitution or elimination. Just for a switch on things, I've been solving most of these by elimination in this scenario. I'm going to solve this one by substitution. So I'm going to pause it and come back. All right, so I filled in my answer or my solution here. Again, I went with substitution. You absolutely could have done elimination. Sometimes I like that better here, but I thought I'd show a different way. So I solved for C. You could have solved for A, substituted it in, and I got 7 adults and 5 children. So once you get the worksheet on this, practice them. Again, things I am looking for: defining those variables, writing the equations, and then solving is just a review. But I am looking for this part of it. If you don't have that part, you're not completing the problems on there. So that's something that's important I'm looking for. All right, bye guys.